Okay, so what we're going to be doing here is we're going to be doing a quick proof of the chain rule. So chain rule, as we know, is based on a composition of functions f of g of x, and we know that the derivative y prime is going to be equal to f prime of g of x times g prime of x. Okay, but in order to prove this, we're going to go back to the limit definition. So the limit definition is y prime equals the limit as h goes to 0 of, in this case, because of our function, is f of g of x plus h minus f of g of x over h. Now, this right here, it is problematic because of the inside here isn't in the form that we would like in order to directly go to this. So what we're going to do is create or multiply by another fraction in order to simplify this, or in order to better manipulate it, I guess. So we multiply here by g of x plus h minus g of x over g of x plus h minus g of x. This is going to give us something to talk about. So in our next line, we're just going to do a quick rearrange. We'll talk about the limit as h goes to 0. And what we're going to do is we're going to flop these two denominators, because since everything here is being either multiplied or divided, then we can multiply or divide in whatever order we want. So this will be f of g of x plus h minus f of g of x over g of x plus h minus g of x times g of x plus h minus g of x over h. Now, one of the rules of limits says if we're doing a limit of all of this product, then what we can do is we can do the limit of this factor and we can do the limit of that factor. Sort of like distribution, but not quite for limits. So we're just going to toss another limit in right there. So if we're doing the limit of this times this, that's going to be equal to the limit of this times the limit of that. Now that's going to give us our first thing right here. We'll notice that the limit as h goes to 0 of g of x plus h minus g of x over h, that's g prime. So we're already part of the way there. The trick is getting this to equal that. So that's the trick right now. So what we're going to do is we're going to do a little substitution here. And we're going to introduce a new variable k. Now this variable k is going to be equal to g of x plus h minus g of x. We do this because we would really like this denominator to be some arbitrary variable which represents a distance, just like this arbitrary variable h represents a distance. But in order to do this substitution, we need to get rid of all of the h's in this limit and make them written in terms of k. So that's this h right here needs to be changed to a k, that h right there needs to be changed to a k, and this one down here needs to be changed to a k. And all three of them work a little bit differently. Now the first thing we're going to say is, let's suppose that h goes to 0. So if we just think about this, as h goes to 0 in this equation, if h goes to 0, then what we're going to be left with is g of x minus g of x. So as h goes to 0, we can see that k goes to 0. So that actually takes care of this one here. The limit as h goes to 0 could be just replaced by k goes to 0 because of this relationship. Now the other one that we're going to do, we need this k is going to replace here. So let me just show you what we've got so far. We're going to talk about in this first limit, the limit as k goes to 0 of, now our denominator is being replaced. That's just, we selected k here as g of x plus h minus g of x. So that's going to replace this denominator. Now, The other one that we need to worry about is this one right here. We need to eliminate the h here because we don't want to have our limit with two different variables in it. So g of x plus h, according to this formula, is actually equal to g of x plus k. Because if k is equal to g of x plus h minus g of x, then if we isolate g of x in this formula, then we're left with g of x plus h will be left with g of x plus k. So when we do that substitution as well inside my f function, then what we'll be left with is g of x plus k minus f of g of x over k times the limit as h goes to 0 of g of x plus h minus g of x all over h. Now, we actually have it here. We're done. Let me just explain how this works. This, the limit as g of x plus h minus g of x over h, that's g prime of x. Okay, that's our limit definition. Now, in this one right here, the limit as k goes to 0 of f of g of x plus k minus f of g of x over k, if we think about g of x being the independent variable of f of x, then what we have here is basically the same as f of un x plus k minus f of un x over k. So this is basically in the same form as some f of a plus k minus f of a over k. If we think about it like that, that's equal to the derivative, sorry, I'll just toss in a limit here as well, as k goes to 0. That right here is equal to the derivative of f at a. But it's not at a, it's at g of x. So this right here will be equal to f prime of g of x according to our first principles definition. So ultimately, our y prime here is equal to f prime of g of x times g prime of x, which is what we were trying to show. So we've got, and that right there is this substitution and this change is the key to understanding this proof. Thank you.